Caves are one of the most striking, complex and useful of all geological formations. They act like the archives of the Quaternary, storing sediment, evidence and fossils all sandwiched in between datable materials like flowstones, where they are protected from erosion and preserved for thousands to millions of years. Limestone produces the best caves, and its secondary precipitate calcite forms stalagmites for paleoclimate reconstruction and coats sediments to form capping flowstones that can be precisely dated with uranium series dating. The most significant human and faunal evidence has been discovered in caves, and our understanding of paleoclimate changes has mostly come from high-resolution cave stalagmites. This makes cave evidence one of the most valuable terrestrial sources of evidence.
As humans, we're quite obsessed with time. We're always trying to save time, make time, slow time down, make it go backwards. Because we understand that everything we do is centered around time. And that makes timing very, very important, especially when we try to reconstruct environmental change. Now, we can see time around us. It's moving fast. There's not much we can do about that. But what if we could go back in time? What if we could step back, like these cavemen, and just go backwards in time to a time where we wanted to reconstruct the changes that were going on? Well, dating techniques allow us to do that.
Dating is a game changer in science. It can make a fossil significant, a stone tool controversial, and a sedimentary layer the evidence for an entire new theory. We have a good idea of what events occurred, from human dispersal to climate change to natural disasters, but mostly we just don't know when they happened.
To find out when, we have a range of dating techniques available to us. These can be divided into numerical, age equivalent, and relative age. Now, numerical age is radiometric techniques and also incremental techniques. So radiometric is all based on the decay of an isotope. So carbon-14 looks at the decay of carbon. Uranium series looks at the decay chain of uranium. And if we know the rate of decay, then we can work out the timeline. The other important radiometric technique is luminescence, and I'll talk about that later. Incremental methods are things like dendrochronology, when things are laid down in layers. And we also have age equivalent, where we know the timing of an event like a volcanic eruption and use that as a marker. And then relative, when we look at a process such as a chemical reaction to chemical alteration and put that along a timescale.
Luminescence dating is a good tool for finding out when. Luminescence is a light-sensitive signal that builds up during a period of uninterrupted dark, such as burial or deposition under other sediments. The signal, in the form of electrons, is energized by natural radiation in the soil and gets caught in traps until it's exposed to light, either naturally by sunlight, called bleaching, or artificially in a lab using diodes or lasers. In both cases, the signal is released in the form of light. The amount of light photons given off is proportional to the amount of time that the electrons were building up during burial. A luminescent signal can be obtained from even a single grain of quartz, allowing us to look at the distribution of signal in the deposit. This has revolutionized our understanding of human arrival and megafauna debate in Australia.
So how do we use luminescence? Well, grains of sand that have a luminescent signal are exposed to sunlight and they are bleached. They then start to build up luminescence within a cave environment during burial. If we take one of these grains of sand and take it back to a red lab, something like the picture here, and we shine light at it or we heat it, it actually gives off a light, and this is what we call luminescence. And this bright signal that can be measured using a photomultiplier, and the signal will come out very, very rapidly when we measure it. Think of the luminescence process like a pinball machine. The little ball is the electrons, and they get energized by natural radiation, and they get fired up into the pinball machine, and it goes around sometime during burial, and then eventually, when light is shone at the electron, it's released and it gives off light. What are the best techniques for dating in Australia? Here's an example of Devil's Lair, found in Western Australia. Very difficult site to date. Originally, when they dated it, they had an age no older than 40,000 because that was using conventional radiocarbon. But they then discovered that there's actually something called a radiocarbon barrier, where radiocarbon can't actually date older than 40. When they changed techniques to luminescence, they discovered that the chronology for the site was actually a lot older. When it comes to environmental change, timing really is everything.